Welcome to a video on complex numbers. Let's start with some definitions. First, we have the imaginary number I. I is defined as the square root of -1. It is always written as a lowercase I. So we just finished studying square roots in the previous video, and we learned that, for example, the square root of 25 is equal to 5 because when we multiply 5 times 5, we get 25. So let's just try to really understand that concept. And that'll help us understand why we need this imaginary number I. It's to help us write answers to problems like this. What if we had the square root of -25? So we're trying to figure out what the answer to that is. Well, it would have to be a number that when we multiply it times itself is going to equal -25. However, even if we put -5's in here and we multiplied them together, it is not going to equal -25. It would still equal the +25. And it has to be a number times itself. So there is no way that we're going to multiply a number times itself and get a negative answer. So we would never get a negative that if we had it under the square root. And that is why a mathematician a long time ago invented this number I. So the way we're going to actually write this is 5I. And we'll work on that some more here in just a minute. But let's finish our definitions. Second, complex numbers. The set of all numbers in the form a plus bi, where a and b are real numbers. And that a plus bi is also known as standard form. So you might see a number like 2 plus 5i. That would be considered a complex number. Now, if the real number part, which is the a, were missing, and we only had just the 5i, that would be called a pure imaginary number. So let's look at this table. The set of complex numbers is a very big set of numbers. It includes all the real numbers as well as imaginary numbers. So let's just look at these categories. Real numbers, we know what real numbers are. 2 is a real number. -5 is a real number. Most of the numbers we work with are considered real numbers. And if you looked at this form, a plus bi, if you just had b as 0, then you wouldn't even see that piece. So 2 is considered a complex number because it could be written as 2 plus 0i. And so forth. So that's true about all real numbers. That's how they fit under the heading complex numbers. Now let's look at this other column, imaginary numbers. These are numbers where the I part is showing. In other words, the b is not 0. Here's an example, 2 plus 3i, and you actually see the I term. If you can see the I term, b is not 0, then it's called an imaginary number. A could be a number like 2, or a could be 0. In this last example, this -4i, the a is 0, and it could, of course, be written as 0 minus 4i, so it still fits this form, and it is called a pure imaginary number. So all of these numbers fit under the big title complex numbers. Now the main thing that we are going to focus on is how do we write the answer when we have a negative under a square root. So the instructions say write each expression as a pure imaginary number. Now I'm going to want you to be able to just look at square root of -9 and say, okay, the answer is 3i. But before we go straight to that, let me just go ahead and kind of show you why it works that way. So we could split up negative 9 into 9 times negative 1. And then we could split that radical into square root of 9 times the square root of negative 1. And the square root of 9 would be 3. And we just saw that the definition of square root of negative 1 is I. So our answer is 3I. And we don't have to show these two steps, this step or this step. We can just go to 3I. You basically think of it as, I'm going to take the square root of the 9, like I normally do, and then I'm going to turn the negative into the I. If the negative is under, now remember, if the negative is out front, the negative just stays out front. It's only when the negative is underneath that it turns into I. So look at number 2. We know the square root of 144 is 12. Radical comes off just like it did before. If I did just plain old 144, the answer to that's 12. So we're doing that part the same. And then we're saying, okay, this negative, we have to deal with that negative underneath, and we do it by writing an I. And we're putting the I behind our number in this case. We do that if there's not a radical symbol in the answer. The I can go behind, like an X would. These problems say, write each expression as a complex number in standard form. Okay, so remember complex number, the standard form is A plus BI. So you've got your constant term first and your I term second. And so for number 1, all we would have to do is just bring down the 3. We would bring down the minus that is in front of the radical. Now the minus that's underneath, that's going to be I. So I'm going to square root the 16, which is 4. The radical comes off. And the negative here, this negative, is our I. It's really negative 1, remember, under the radical becomes the I, but the negative out front stays. Don't think of it as you're going to multiply those negatives, because that will not work. Look at number 2. So again here, we're going to keep the 8. We just drop down that sign that's in front of the radical. The square root of 169 is 13, and the negative underneath becomes I. So our standard form is 8 plus 13I. Let's do a couple more. These are slightly different because they have a fraction. We would first simplify the radical, just like we were doing on the previous examples. So we're going to bring everything else down, bring down the 15, bring down the minus that's in front of the radical, and then just do the square root of negative 25. The square root of 25 is 5. The negative under becomes an I. So we put 5I after this minus sign, which still has to be there. Then go ahead and keep that 5 on bottom. So simplify the radical first. Let's write that. Simplify the radical first. Now, once you've done that, to divide by 5, you have to divide each term on the top by 5. So you're going to write it like this: 15 divided by 5 minus 5I divided by 5. It has to go into both. You cannot cancel those 5's out. You're not allowed to cancel over addition or subtraction. Only multiplication, so do not cancel. Just write the 5 under each. Then simplify each term. So we would do 15 divided by 5 is 3. Bring down the minus. 5 divided by 5 is 1. So it'd really be 1 times I, but 1 times I is just I. So our answer is 3 minus I. And that's the standard form. We want the number term first, the I term second. Let's try another one of those. So we're going to simplify the radical first. We're going to bring down the 4 and the plus. We're going to simplify square root of negative 100. That's going to equal 10i. Radical comes off, so this right here becomes 10i. And bring down the 12 on bottom. Now to simplify further, we are going to put the 12 underneath each term that's on the top. And this time the top's not divisible by the bottom, but if you can simplify the fraction, you should always simplify it. So 4/12 we can divide top and bottom by 4 is going to become 1/3. And then 10/12 we can divide top and bottom by 2, becomes 5/6. And the I am actually going to write to the side in the middle. So it's now in the form A plus BI. This would be considered standard form. However, if you left the I on top with the 5 and called it 5i over 6, I would still accept that. So you can put the I on the top or in the middle when you have a fraction. Just do not put it on the bottom. Okay, this was kind of a short video, but that's what we needed to learn about complex numbers. And so I'm going to go ahead and stop here, and then I will do another video to talk about nth roots.